Right. Good day, Matrix. Welcome to another episode of Corona Maths. I hope you can see this. But what we're going to be doing today is finding the equations of tangents to curves. Finding the equation of tangents to curves. So to do that, generally, finding the equation of tangents to curves, the method you're going to use is, your first step is to find the y-coordinate. So we've got a curve over here. Our first step is to find, you'll be given the x-coordinate, where here's a tangent, or x-coordinate where the tangent touches the curve. So the first thing you have to find is the y-coordinate at your point of contact, because that's going to be the only point you can find on the tangent. Okay, so this is the common point between the tangent and the curve. Okay, so to find the y value, okay, at that point, you simply sub into your original function like you've always done, okay, into your original function f. So you find the y-coordinate at the point of contact by subbing the x-coordinate at contact into the graph. In other words, if you've got a point, this coordinate here was x1, the y-coordinate would be f of x1. If that was 2, the y-coordinate would be f of 2. Right, now you've got a point on your tangent, okay, but you can't find another point because we don't know another point of contact. So I've got a point, I've got an x and a y coordinates. Now I going to find the gradient at that point. And remember what we said before, the gradient at a point means the gradient of the tangent at that point. And how do we find the gradient at a point, or the gradient of the tangent at a point? We sub into your derivative equation. So once you've got the point of contact, the next thing is to find the gradient. How do you find the gradient? You find the derivative for that function. Okay. Then you sub your x-coordinates into the derivative equation. So step 2, find the gradient of the tangent by subbing into the derivative of the function. And so if you're working with the point x1, then your gradient will be f dash of x1. Right, so now you've got a point, okay, on the tangent. You've also got the gradient, which you found by subbing into the derivative. So now it's just a question that you'll be doing since nursery school. You've got a straight line, you know a point on the straight line, and you know the gradient of the straight line. Okay, so you're going to go use y is equal to mx plus c. Your objective is to find m and c. Well, you know m already. Okay, and then to find c, you can sub in your point, x and y, and that'll give you the equation of the tangent. You can, of course, obviously use that the y minus y1 is equal to m, x minus x1, if you are comfortable with that. Right, I'll give you some time to get that down. I hope you can see it, as I said before. Apologies for the light. Right, so I hope you got that down. Okay, so the first example we're going to do is sketch. First of all, I want you to sketch f of x is equal to x squared minus 4. And then I want you to find the equation of the tangent, I should say 2f of the tangent 2f. Find the equation of the tangent 2f at x is equal to negative 1 and x is equal to 0. Right, first of all, go draw the curve and then draw in where those tangents will be. Okay, so the function f of x is equal to x squared minus 4 goes through negative 4 over here. We'll have intercepts at 2 and negative 2. So it's a simple parabola that you did just after you popped out the womb. So here is f of x is equal to x squared minus 4. Right? First question says find the equation of the tangent at x is equal to negative 1. So we're looking, excuse my graph, for a tangent. This is where your tangent would be over here. Right? Touches a curve at one point at x is equal to negative 1. So at the moment, all we know about the straight line, about the tangent, is this x is negative 1. So that's not enough. So there are always two steps. What are your steps, first of all? So at x is equal to negative 1, well, we need a point on the tangent. To find a point on the tangent, what do? Well, here's your only point of contact. So this is the only point we can find. Okay, it's on the curve f. So your y value, the y coordinate there will be equal to f of negative 1. Right? Go find your y coordinate. We get y is equal to, the equation we're working with is x squared minus 4, don't forget. So y is going to be equal to negative 1 squared minus 4, which is negative 3. So what do we know about the straight line at the moment? We know it goes through the point when x is negative 1 y is equal to negative 3. That's not enough to find the equation of that straight line, so I still need to find the gradient. Okay, so your steps are number 1, you're going to find a point. Okay, then you're going to have to find the gradient of the tangent. Okay, and how do you find the gradient of the tangent? Well, we're going to sub into the derivative function for our original graph. So, first of all, the original function was f of x is equal to x squared minus 4. Okay, so your derivative function f dashed of x is going to be equal to 2x. We want the gradient at x is equal to negative 1. So my gradient is going to be equal to f dashed of negative 1, which is equal to 2 times negative 1, which is equal to negative 2. So what have you got now? Well, we've got the straight line goes through the point negative 1 minus 3, and we know now that the gradient, which looks right, because it's going left to right down, is negative 2. So here's my straight line. Negative 1, negative 3. I know the gradient is equal to negative 2. So you've got a point, you've got the gradient, so go find the equation of the line, like you've been doing forever. So, to find the equation, okay, you're going to say y is equal to mx plus c. Well, you know the gradient m is negative 2, so y is equal to negative 2x plus c. But y is equal to negative 2x plus c. Okay, now we're going to say sub in the point. So I'm going to have y value is negative 3 is negative 2 times negative 1 plus c. So that's going to be positive 1 minus 3 minus 1 is minus 4. Which, okay, so y is equal to negative 2. I've spotted my deliberate mistake. Negative 2 times negative 1 plus c. So I get 2 minus 3 is equal to 2 plus c. So I get minus 5 is equal to c, which looks right because it's saying that this tangent carries on and it will cut the y-axis at minus 5. So c is equal to minus 5. So your final answer is y is equal to negative 2x minus 5. Y is equal to negative 2x minus 5. So what are your steps when you're finding the equation of the tangent? Okay. Well, first of all, you need the y-coordinate at that point. How are you going to get that? By subbing into the original equation. Then you're going to need the gradient. How are you going to get the gradient? Okay. By subbing into your derivative equation. Once you've got the point, okay, and you've got a gradient, that's enough to find the equation. To find the equation, you're going to use y is equal to mx plus c. So the equation of the tangent at x is equal to negative 1 is y is equal to negative 2x plus 5. Right, go try to find the equation of the tangent at x is equal to 0. Right, the next question was to find the equation of the tangent at x is equal to 0 on f of x is equal to x squared minus 4. Well, you can see here the gradients are negative, and they become positive at the turning point, or at the stationary point. Okay, we can predict that your gradient should be equal to 0. Okay, so in other words, this is going to be a horizontal line. But just to show you, in case you didn't recognize that, okay, you've got f of x is equal to x squared minus 4. So we said when you're finding the tangent, the two main strategies. Number 1, you need the point of contact. Number 2, you need the gradient. And that will then be enough to give you the equation. So this point over here is what? Well, to find it, it's at x is equal to 0. So y will be equal to f of 0. So y is going to be equal to 0 squared minus 4, which is negative 4. So the point of contact is at, you don't have to go through all of this, by the way. If you know the answer straight away, you can just write it down. I wouldn't expect any working here, to be honest. So there's 0, negative 4. Now, what's the gradient going to be? Well, your gradient, to find the gradient, I need my derivative equation. So my original equation is f of x is x squared minus 4. So my derivative equation is going to be 2x. And your gradient at x is equal to 0 will be f dashed of 0, which is 2 times 0, which is 0. So this is what, as we expected, the gradient is negative. At the turning point, it's equal to 0. So what have you effectively got here? Well, you've got a horizontal line okay, because the gradient is 0. And what's the y-coordinate always along that point? Well, the y-coordinate is -4. So the equation of the tangent at x is equal to 0 is going to be y is equal to -4. It's a horizontal line because the gradient is 0. Okay. So if you, in future, if it's at the turning point, if you're looking for a tangent at the turning point, it's going to be a horizontal line. Okay. And the equation will be y is equal to whatever the y-coordinate is of the stationary point. Okay. Get that down. Dum-de-da. Righty, human beings. Okay. You've got notes, classroom maths. Okay. And all our examples are going to come from exercise 8.7. Okay. That's for you to do on your own. And we're going to do as examples 2C, E, 2C, 2E, and 3B. Okay. So question 2C says, find the equation of the tangent to y is equal to -6/x at x is equal to -2. Well, over here I've drawn the function y is equal to -6/x. Hopefully you know that that's our hyperbola. We want the equation of the tangent at x is equal to -2. Okay, so there's the tangent over there to that hyperbola at x at -2. So what are two steps when you find an equation of a tangent? Well, first, it always use two processes. Number one, I need the point of contact. In other words, I need the y-coordinate at your point of contact. And number two, I need the gradient. Right, go find those two things. Go find the point of contact, go find the gradient of the tangent. Right, so point of contact, what I do, I sub into the original equation. So I'm looking at the equation of y is equal to -6/x, but I want to know what happens at x is equal to -2. So if I combine those two things, I get y is equal to -6/2, which is equal to 3. Right, so that's your point. So your point of contact, which you've worked out over here, is -2, 3. That's the only point we can figure out, okay, on the tangent, because there's no other point of contact. So now I've got a point, and now I need the gradient at that point. To find the gradient at the point, or the gradient of the tangent at that point, what I do, I sub into the derivative equation. So the original equation is y is equal to -6/x. So I've got to go differentiate that to get the derivative equation. But at the moment, it's not in differentiable form. Why not? Because there's a variable in the denominator. So the equation we're going to write as y is equal to -6x to the -1. Now, the variable is in the numerator, so I can differentiate. So my notation will be dy dx. Times that is 6. Take away 1 from the exponent, I get 6x to the -2, which is the same thing as 6/x squared. With graphs, makes more sense if you get things into positive exponents. Okay, so there's my derivative equation. Okay, 6/x squared. But I want the gradient at x is equal to 2, okay, -2. So your gradient is going to be equal to 6/2 squared, which is going to be equal to 6/4, which is 3/2, which is 1,5. Let's just leave it as 3/2. Okay, so your gradient, 6/x squared, 6. So what have we worked out? 6/4, 3/2. But the gradient here is equal to 3/2. So I've got a straight line. I know the gradient is 3/2. I know a point on the straight line is -2, 3. So I want you to now combine those two facts, that your gradient is 3/2, and we know that it goes to the point -2, 3, and you're going to go use y is equal to mx plus c in order to find the equation, or you can use y minus y1 is equal to mx minus x1. So the gradient is 3/2, so I've got y is equal to 3/2 x plus c. I've got to sub in a point. I sub in -2, 3. Okay. Sub in -2, 3. There it is over there. So I get 3 is equal to 3/2 times -2 plus c. 2's will cancel. I'll get 3 is equal to -3 plus c. So 6 is equal to c. So now I've got c is 6. Remember, your objective if you're using this method is to find m and c. Okay, so your final answer will be y is equal to 3/2, or you can write 1,5, 3 over 2x plus 6. Doesn't make sense looking at the graph. Well, the gradient is 3 over 2, the point of contact. The y-intercept, sorry, looks like 6 is a viable option. Okay, so it looks okay to me. Right, so there's our answer. Y is equal to 1,5x plus 6. All right, get that down. Right, give the next one a go, which says find, this is question 2E from Classroom Maths. The question says find the equation of the tangent to y is equal to negative 2x cubed minus 6x squared plus 4 at x is equal to negative 1. Right, if I had autograph here, I'd show you the curve. We don't. It's a cubic function. Okay, I'm not going to try to draw it for you. Okay, but anyway, okay, don't worry about it for now. Right, so give that a go. Remember, what are two things? You want to find the point of contact at x is equal to negative 1, and you want to find your gradient at x is equal to negative 1. Okay, so to find the point at x is equal to negative 1, your y value is going to be negative 2 times negative 1 cubed minus 6 times negative 1 squared plus 4. And believe it or not, we can do that without a calculator. You're going to get negative 1 times negative 2 is 2. Negative 1 squared is 1 times negative 6 is negative 6 plus 4. So I get y is equal to 0. Let's just check that. Negative 2, negative 1 cubed. Negative 2 times negative 1 is 2. Negative 1 squared is 1. Negative 6 plus 6. So our point is going to be negative 1, 0. Right. So we've got a point. And then we've got the gradient at x is equal to negative 1. Okay, and to find the gradient at x is equal to negative 1, we need the derivative equation. So dy dx is going to be equal to negative 2 times 3, just using this, 3 times negative 2 is negative 6x squared minus 12x. The derivative of 4 is 0, so that disappears. Okay, and now I want the gradient at x is equal to negative 1. So that's going to be negative 6 times negative 1 squared, do my abs exercises, minus 12 times negative 1, which is it going to be? 1 times negative 6 is negative 6, plus 12, negative 6 plus 12 is 6. So your gradient is 6. So what do we have? We have a straight line that goes through the point negative 1, 0, which is over there, and it's got a gradient, pretty steep, of 6. Right, so to find the equation of that line, I'm going to use y is equal to mx plus c. I'm just going to sub them all in at once. So your y value is 0, so I get 0, m is 6, x is negative 1, plus c, so I get negative 6, move it across, and I get 6 is equal to c. So your equation is going to be y is equal to mx plus c, but we know that m is equal to 6, so it's 6x, and I know that c is equal to 6. So your final answer is y is equal to 6x plus 6. Again, process over and over again. Find the point at contact, find the gradient at contact, to find the point at contact, sub into the original, to find the gradient at contact, sub into the derivative, and then go use y is equal to mx plus c and find the equation. So the equation is y is equal to 6x plus 6. Right, get that down. One more example. Right, welcome back. Okay, so your next example, question 3b, is from exercise 8.7 of Classroom Maths. Okay, and you've got f of x is equal to x squared minus 4x. The question says, find the equation of the tangent to f which is parallel to y minus 2x minus 3 is equal to 0. So this question is phrased in a completely different way. So it is, I'm just going to press pause for a sec. Sorry about that, we had some stuff going on in the kitchen.
Are you writing neatly?
I'm trying to write neatly. Okay, so we're trying to find this whole situation. Okay, find the equation of the tangent of 2f which is parallel to that. So we don't know, the problem is here, we actually don't know what the x value is. So, well, don't panic, just take what we know. What do we know? Well, here's, by the way, is the curve f of x is x squared minus 4x, turns at 2 minus 4, it's got intercepts at 0 and 4. Right, and so we want a tangent that we want is parallel to y minus 2x minus 3 is equal to 0. In other words, it's parallel to y is equal to 2x plus 3. In other words, we want our tangent must have, it's parallel to this one, it must have the same gradient. What's the gradient of this? It's 2. So our tangent that we're looking for must have a gradient of 2. So we want to find, okay, what gives us the gradient of the tangent? The derivative. So they're telling us, by telling us, this is a complicated way of telling us, that the gradient of the tangent that we're looking for is equal to 2. So I've got the gradient is equal to 2. So now I'm going to use this to find out what the x value is. Okay, so I've got f dash of x is equal to 2. And we know that f of x is x squared minus 4x, right? Okay, in other words, what's the derivative equation? F dash of x is equal to 2, but the derivative is 2x minus 4. So our with the tangent that we're looking for, 2x minus 4, that's the derivative equation, that's f dash x is 2x minus 4, must be equal to 2. So I get 2x is 2 plus 4, which is 6. So I get x is equal to 3. So what we're looking for is the equation of the tangent at x is equal to 3, which is somewhere over there. So I'm looking, here's my tangent over there. So the tangents I know now, okay, happens that x is equal to 3. Don't go find the gradient again, we've got that. Okay, the gradient of our tangent, well, it's parallel to that, so the gradient is 2. So I've already got my gradient is 2. Now I've got an x coordinate, the point of contact is at 3. Okay, so now I need to find the y coordinate that goes with it. So when x is equal to 3, the y value is going to be f of 3. So y is equal to 3 squared minus 4 times 3, which is 9 minus 12, and 9 minus 12 is negative 3. So this is the point, 3, negative 3. Okay, so I've got, for my tangent, I've got the gradient is equal to 2. I know that it goes through the point, 3 minus 3, and that's enough to find the equation. So just for a change, we'll use, I'll stick to y is equal to mx plus c. M is 2, so y is equal to 2x plus c. To find c, I sub in the point. Negative 3 is equal to 2 times 3 plus c. So negative 3 is equal to 6. So negative 9 is equal to c. I always make, if I had a graph, I'd check, well, that looks like it could be right. Not to scale, obviously. The y-intercept is negative 9. So your final answer is y is equal to 2x minus 9. And I've got the equation that will be parallel to that, okay, etc. So just take what you always be given. What were you given? By telling you this, it's parallel to that, they're giving you the gradient. Okay? So it's a complicated way of telling you that the gradient is 2. What gives you the gradient? Okay, the derivative, so we don't know where the derivative is equal to 2. Solve that, we get the x value, find the y value that goes with it, combine everything, and we've got the equation of the tangent. Alright, so just the last little thing, equations of normals. Okay, it doesn't apply to any of you. Okay, a normal is, and the definition of a normal is perpendicular to a tangent at the point of contact with the curve. Okay, so in other words, okay, let's just have a look at an example and I'll explain it. The example I want to do with you is find the equation of the normal to f of x is equal to negative x squared plus 4 at x is equal to 1. Well, here's the curve, f of x is equal to negative x squared plus 4. Okay, and we want the equation of the normal at x is equal to 1. Well, the tangent would be over there, and all a normal is, it's perpendicular to the tangent at point of contact. So if you ever ask to find the equation of normal, your key idea is that the gradient of the tangent times gradient of the normal is negative 1. Why? Because by definition they're perpendicular to each other. So gradient of normal is going to be negative 1 over the gradient of tangent. In other words, the negative reciprocal of the tangent. So what's your process going to be? Well, you're going to find, the only difference is, you're still going to find your point of contact. Okay. Then you're going to find now your gradient of your tangent by subbing into the derivative equation. Once you've got the gradient of your tangent, to find the gradient of the normal, you're going to find the negative reciprocal, and then you're simply going to use y is equal to mx plus c. So give it a go. Right. So your point of contact happens at x is equal to 1. On the curve, f of x is equal to negative x squared plus 4. So if you combine those two things, we're looking for the point will be f of 1, which is negative 1 squared plus 4, which is going to be equal to 3. So our point is 1, 3, which is over there, which makes sense. Okay. The next thing I need is the gradient, and the gradient is going to be found by subbing into the derivative. So f of x is negative x squared plus 4. So find your derivative equation, which is going to be negative 2x for that curve. So we're looking for the gradient at x is equal to 1. So the gradient is going to be equal to f dashed of 1, which is equal to negative 2 times 1, which is negative 2. Does that make kind of sense? Well, there's 1, 3. Okay, the gradient of the tangent we've worked out. The slope of this line is negative 2. The question said find the equation of the normal. So if this gradient is negative 2, what's the gradient of that line? Well, they're perpendicular to each other. So this over here was the gradient of your tangent. So your gradient of your, that, you can say your normal is perpendicular to your tangent. So if the gradient of your tangent is negative 2, the gradient of the normal will be the negative reciprocal. So it'll be gradient of your normal will be equal to a half. So the normal over here is equal to a half. So what do I know about this line I'm looking for? Okay, it goes through the point 1, 3. This is the normal, and it's got a gradient of a half. So the question is, find the equation of that line that has a gradient of a half and goes through the point 1, 3. So if I use y is equal to mx plus c, I've got y is equal to a half x plus c. Okay, subbing 1, 3, I get 3 is equal to a half times 1 plus c. 3 minus a half is 6 over 2 minus 1 over 2, which is 5 over 2 is equal to c. So the equation is y is equal to a half x plus 5 over 2. If you want to make it pretty, you can multiply by 2 and you get 2y is equal to x plus 5. But that's not necessary. You're welcome to have y is equal to half x plus 5 over 2. So if you ask to find the equation of a normal, okay, what do? We'll find the point of contact, find the gradient of the tangent, they're perpendicular, so then we can get the gradient of the normal by flipping it around and changing the sign. And that is the end of the examples. And what I want you to do on your own is classroom maths, exercise 8.7. Okay, the questions we didn't do as examples, I will send you the solution. Okay, good luck out there, and may the force be with you. Arrivederci.